Hey guys, welcome back to another one of my videos. So here we'll be going through the entirety of the January 2019 paper, and this is from IGCSE Edexcel, and this is the 1H1. And as always, you can use a calculator, and I recommend it all the time. Even for easy problems, use a calculator. You don't want to lose any simple marks. Okay, now as an overview, this paper was slightly challenging. There is a few questions here and there which can be a bit tricky, but overall doable. So let's have a quick look here, and as always, you're given all the necessary formulas you need. Some you might need a few more, but overall you have more or less most of them. So let's do this. Let's start with number 1, yeah? Okay, so A, factorize fully 4p plus 6pq. Now all you have to do is look at both terms and see what they have in common. Well, let's look at the numbers, 4 and 6. They're both in the 2 times table, so you can both divide by 2. They both got p, so we can divide it by p. So that's what factorizing is. Literally find a common factor. So if you took out 2p from 4p, to make 4p you need to multiply 2p by 2. To get 6pq, you took out 2, so you need to put 3 back in because 2 times 3 is 6. You took out p, so it's gone, and you're left with a q. And that's it. And all of this should go over here. Next one, B. Expand and simplify e plus 3 times e minus 5. Now this is just easy, yeah? All you have to do is literally just multiply term by term, yeah? So like this. It's always good to draw these arrows, by the way, yeah? So you got 3 in e and 3 in 5. So doing it step by step, you can do e times e, which is e squared. E times minus 5 is minus 5e. 3 times e is plus 3e. And then finally, 3 times minus 5 is minus 15. And then collect like terms. So the middle two term, yeah, you always combine it. So minus 5e plus 3. If you're not sure, in your calculator, minus 5 plus 3 will give us minus 2e. So we can get e squared minus 2e minus 15. And again, this should go here. Next one, yeah, solve. Let me change the pen. So solve y equals 2y plus 1 over 5. So this is straightforward. Every time you have a fraction, always clear the fraction because we don't like working in fractions. So we need to multiply 5 across. So if you cross this 5 and stick it here, you're going to get 5y equals 2y plus 1. Now move all the y's to the left. So to move 2y across equals something to subtract. So it'll be 5y take away 2y, which is 3y. You're left with 1 on the side, on the right side. And then to get rid of the 3, you've got to divide by 3. So it'll be y equals 1 over 3. And we can leave it here as 1 over 3. And that's it, guys. That's number 1 done. So let's look at 2 now. Oof, these kind of ones. So you're given 2 triangles, A and B, okay? And they'll probably ask us to do some sort of transformation. Okay, so A, describe fully the single transformation that maps A onto B. Okay, so this one's, so this one you usually need a tracing paper, but I'm going to show you guys a nice method. So I'm going to switch the page for a second. Okay, so I'm using PowerPoint to do this question. Now, the way this works, you just have to ask yourself what happened between A and B. Well, if you look at the shapes, it looks like it's sort of rotated 9 degrees. So the shape was originally like this, and then somehow it became like this. And you can only do this if you rotate it 90 degrees clockwise. Okay, so that's what we can definitely say, yeah? That definitely happened. Now, the easy way to do this, and this is without a protractor, guys. This is literally an observing method. What I would do is focus on 2 points, yeah? For example, let's focus on the bottom point here. And this means if you're focusing on this point here, then this equivalent point would be there. So we're going to highlight both of them. And then what I want you guys to do is to draw a straight line connecting them. So it looks a bit like this. Okay. Now the point of this is that because you know it's going to be a 90 degrees clockwise angle, we need to find out where the center of rotation is. Now one thing to note here, it's not here. It's definitely not in the middle of the line. It feels like it, but it wouldn't. Because if you rotate it from here, this will end up somewhere in the wrong place. So what we need to do is find out where the 90 degree angle is. So it's going to be something like a 90 degree triangle. Now this is a super easy way. And I'm going to show you. So let's take 2 different lines here. And I'm going to connect this over here for a second, yeah? And then this is going to be a line. I'm going to use this line as well and connect it to this corner too. And all we have to do is literally just move the line about until we have the same distance. I'll show you what I mean. So for example, let's just connect him over here for a second. Yeah, let's say this point over here. And then this is going to go here. What this means now is that we just look at the lines. So from this point to here, you would have gone 4 down and 1 across. Whereas from B, you would have gone 2 and 5 across. So it looks like this line is longer. And what that means now is that we need to try and make it shorter. So let's move it to the right a bit here. So let's move it one block at a time. Now this is just trial and error, yeah? Now look at this line, we can see now this is going 4 and 2. This is going 2 and 4. And that's it, and this is perfect. So if you're traveling the same distance, what that means is that you've just made a right angle triangle. And that's it. You've literally found the point of rotation. This would be the point of rotation. And we've done it, guys. So we say that the center is -2, 3. So this would be -2 and 3. And we say that A to B had a rotation about center -2 and 3. That's it. So if you guys need any tips on this one, because this is probably the hardest version without tracing paper, my tip is always connect the lines and then literally find a right angle triangle somehow. Just use trial and error until you make 2 similar lines with the same distances across the points. Yep. And that's it, guys. Let's move on to the next bit. Okay, guys, so we're back on the paper now, so I just copied it all here. So let's look at part B. So on the grid, translate triangle A by the vector 2 minus 5. Okay, translate literally means move the triangle across by a direction of 2 to the x-axis and downwards by 5 on the y-axis. Okay, now label the new triangle C. So let's do that. So triangle A, we're going to move it 2 across. So what I would do is, again, I'll change the color pen. Pick a corner, so let's say this corner, and move it 2 to the right. So end up here. And then it said move it 5 down. So if it was -5, it means down. If it's +5, go up. Same thing for the x. Because it's +2, you move to the right. If it's -2, you move to the left. So moving it 5 down is going to go 1, 2, 3, 4, 5. So this means that this top right corner is going to appear here. And just copying the shape of the triangle, it's going to be something like this. And then labeling it C. And that's it, guys. It's literally done. On the grid, enlarge triangle D with a scale factor of half and center of -4, 2. So thankfully they gave us a center this time. Now to enlarge the shape, there's literally a nice trick here. So what you guys could do is literally start from here and literally cut through every single point like that. And do the same for every corner. And then all you have to ask yourself is, okay, so it says enlarge with a scale factor of half. What that means is that you have to half the distance. So if the distance from here to here was originally, let's just imagine this is 4 across or something. You want to find half the distance, and half looks like somewhere here. So this means this corner is now going to appear here. And again, from here, from this to the second line, about half the distance should be around here somewhere. So it should be like here. So if you connect it, this is the new shape. And you kind of guess. This one is 4 lines down. Half of 4 lines is 2 lines down. So you draw 2 lines down. And then just connect the shape. And there you have it, guys. This is literally a projection. Okay, number 3. So here is a biased 5-side spinner. Okay, so the word biased here means something isn't fair. So in terms of probabilities, all of these colors are not the same value. So they're not 1 out of 5 chance each. Okay, they could be higher, they could be less. So we don't know. We got to check the table. So it says here that when the spinner spun, it could land on either red, blue, green, brown, or yellow. So any of the 5 colors. And the table here gives the probabilities that the spinner lands on one of these 3 colors. So we know them already. We just don't know what brown and yellow is. So we probably need to figure it out. Now, let's see what the info below says. When the spinner is spun just once, the probability that the spinner lands on brown is going to be 0.06 more than the probability that lands on yellow. Okay, so we're trying to say that whatever yellow is, let's call it X, is going to land, if it's going to land on brown, it's going to be whatever yellow is plus 0.06. So it'll be yellow plus 0.06. So that's one way to understand it, yeah? And by the way, all probabilities must always add up to 1. So actually, let's go ahead and work out these probabilities, yeah? Let's go ahead and plus all this up. So we can say that 0.15 plus 0.26 plus this plus that equals 1. So just tidying this up. So in your calculator, let's add up these numbers: 15, 26, 33, and 0.06. So you should get 0.15, 26, 33. So adding all of them up, you should get 0.80 plus 2x equals 1. Okay, now you just solve it as if it was a normal algebra question. So minus 0.8 across, you can get 2x equals 0.2 or 20. Half it, you can get 0.1. So that's it. So we got the values. So yellow is going to be 0.1. X plus 0.06, so 0.1 plus that will give us 0.16. So let's just update the figures. Okay, now we got all of that. So what do they want us to do? So Janine spins the spinner 150 times. Work out an estimate for the number of times the spinner lands on yellow. So you basically want to spin it 150 times. How many times does it land on yellow? Well, 150 times that probability of it landing on yellow, which is 0.1. And that's going to give us, this is going to be easy maths, but as always, put this in the calculator and you should get 15. That's it. So you got 15 times. And you get 4 marks for that, so it's not really too bad. Okay, it's actually not too bad. Let's move on. So number 4, information about the price of gold. So let's see, the price of 1 ounce of gold in dollars is $1,126.5. And that was in the 1st of Feb. And then 1 month later, it went up a bit. Now A, work out the percentage increase between these two dates of these two gold figures. Now for these kind of questions, there's a really nice formula you could use. We can always use that the original value times some multiply, let's say 1 plus a rate, will always give us a new value. So again, this is the old value times a multiply. So the R here is, in this case, a percentage increase would be the R, and that'll give us a new value. Now all you have to do is literally replace this with what you know. So we know that the old value was 1126.50. So we can say 1126.50 times the multiplier must give us a new value of 1236.50. Now thankfully, all you have to do is literally just rearrange and solve for R. So to do this nice and easy, you could divide the old value across and then minus 1. So we can say, let's do it step by step. So dividing this across, you can have 1 plus R equals 1236.50 over 1126.50, and then literally just minus R across. So subtracting 1 across, and you got your rate, which is all it is. So let's go ahead and put this in the calculator. So you're going to get 1236.5 over 1126.50 minus 1, and you're going to get some kind of decimal answer. Now because they want a percentage, you want to multiply your decimal answer by 100 to change it to a percentage. So answer times 100, and you should get to 3 significant figures, the first 3 numbers, 9.76%. And that's it. That's this part done. Now B, the price of 1 ounce of gold on the 1st of Feb was the same amount, so it's actually the same info. The price of gold increased by 19% from the 1st of Feb to the 1st of July. Okay, work out the price of 1 gold on the 1st of July. So they told us everything. So we're going to use the same formula, and this time we got the original value, which is 1126.50. We got a rate, which is 19%, and they want us to find the new value. So let's put it down here. So old value 1 plus R equals new value, guys. Popping in the numbers, so we got 1126.50, 1 plus 19%. And remember, using a percent button here. And let's see what it gives us here. So let's put it down. So 1126.50, 1 plus 19, and remember to use the percentage button for 19. And you should get 1,340 point, and let's see, round it to the nearest dollar, yeah? Okay, no, let's just copy the whole thing down. Round it to the nearest dollar, you can get $1,341 because you got 0.5, and that's gonna boost it up. That's it, and that goes right here. Not bad. Okay, number 5. Oof. All right, so this is easily one of my favorite questions. So let's check it out. So you got B, C, D, and A, F, E are straight lines. So it's these 2 lines here, yeah? So B to D and A to E. Show that those 2 lines are parallel. Give reasons for your working. Well, one thing that you want to say, even though it looks obvious, we can't just say it looks parallel, even though it probably is. The way to prove it is to use some properties, yeah? If you look at the shape here from, let's say, from B to C, and then C to F, and then F to A, so this kind of shape, you've probably seen it before. Now, this is known as an allied angles, because we got to imagine that this top angle is A and this top angle is B. And we say that the sum of A and B equals 180 degrees. And if this is true, then those two pairs are allied, meaning that it's definitely parallel, yeah? So that's one property. Now, before we can even assume that, we can't just assume it, by the way, guys. Notice how we got x values everywhere. What we could do is do something that is obvious, which is the straight line across. Because we know that the angle on the straight line adds up to 180 degrees. Okay? So let's go ahead and add up these two, 4x plus 15 and 30x minus 5, make it equal to 180. Okay? So adding both pairs, you can get 34x. 15 add minus 5, so 15 take away 5 is plus 10, now equal 180. Okay, now solving this one, so minusing 10 across and then dividing 34, you should get 5, so x should be 5. Now what does this mean? This means that if you had to plug in x equals 5 to these two angles here, and if they add up to 180 in the end, then you've done it. So using the same x value, and if you get 180, you've proven it. So let's test the theory, yeah? Let's plug in x equals 5 to both these angles, yeah? So when x equals 5 to this one, so you got 4 times 5 plus 15. So 4 times 5 plus 15, you get 35 degrees. Alright, so far so good. Let's plug in 5 to 20x plus 45. So 20 times 5 plus 45, I got 145. And, you know, if your mental math is sharp, then you can see it. But if you're not sure, add up the two figures and you get 180 degrees. So yes, this is proven. So they're allied angles. So for the x, so you can say when x equals 5, you can say angle BC, so what's this, BCF? So angle BCF is equal to angle AFC. Angle AFC. Oh, sorry. These two angles add up together will make 180 degrees. And that's it. And this will be classified as an allied angles. Okay, question 6 now. Let's see. So complete the table of values for y equals x squared minus 5x plus 6. Oof, easy stuff. All you gotta do is literally plug in the x values and get the corresponding y values. So for example, when the people who created this plugged in x equals 0, you get 0 squared, which is 0, minus 5 times 0, which is 0, plus 6, which is 6. So all you gotta do is plug in 1. So you're gonna have, let's say, so y equals 1 squared, which is 1, minus 5 times 1, which is 5, plus 6. Put this in the calculator or do it all at once. And what should you get here? So, and you should get 2. Do the same thing with when x is 5, yeah? So you're going to have y equals 5 squared minus 5 times 5 plus 6. And doing so will give us 6. Okay. Now, one thing to note, yeah? Because this is a quadratic equation, and quadratic means that you have an x squared, an x term, and a regular term, or at least it starts with x squared, you're going to get a symmetrical pattern. So you can see bang in the middle that these values across and these values here have the same pattern. So 0, 2, 6, 0, 2, 6. Now, let's look at part B, yeah? So we're going to probably draw this. So on the grid, draw this graph, which is this equation, which is these points here, for all x values between 0 to 5. So in other words, plot every point. Let's try this out, yeah? So let's start in the middle because it's nice and easy. So when x is 2 or x is 3, y is 0. So when x is 2, y is 0. When x is 3, y is 0. Next one, the outer, yeah? So when x is 1 or x is 4, y is 2. So 1, x is 4, y is 2. And then lastly, you got when x is 0, y is 6. And on the same side, when x is 5, y is 6. Now we just have to make a U-shape curve. So I haven't got the right tools for this one, so I'm going to just do it freehand. But anyway, you're going to do it freehand anyway. So it's going to dip below the curve because it's a U-shape. It's a bit hard to curve it nicely. But yeah, as long as you can make some sort of U-shape, yeah? Where it hits the line at 2 and 3. Something like that, yeah? If you can pull off a shape like that, then you've got it. Okay, next. Okay, let's look at part C now. So by drawing a suitable straight line, alright, so it's going to be a straight line, on the grid, find estimates for the solutions of this equation. Okay, now you're probably thinking, like, where's this coming from? You could solve this using, I don't know, simultaneous equations or using a quadratic formula, but what I want you to do is somehow relate to this curve. Now what I want you guys to do is just look at this curve again, because that's what we just drew. Let's copy it down there. So we're gonna have, y equals x squared minus 5x plus 6, yeah? Just double checking, yep. And now looking back at the top one, we can see they're almost similar. The only difference is, if you look at the left hand side, they go x squared minus 5x, which checks out, but they're missing a plus 6. So let's go ahead and plus 6 to this equation, yeah? Plus 6 across. So what happens here, it now becomes x squared minus 5x plus 6 equals 6 minus, now minus 7 at 6 is minus 1. And there we have it. So what they're trying to say is to show when this curve equals this straight line. So the curve intersecting with a straight line. Okay. Now to plot x equals minus 1, which is the same as y equals x minus 1, just pick two corners. For example, you can say when x equals 1, you're going to have 1 take away 1, which is 0. So you're going to have 1 and 0. You can say when x equals 2, 2 take away 1 is 1. So that'll be x is 2, y is now 1. So just plot these 2 points and connect a straight line. So 1, 0 is going to be, let me change the color of the pen. 1, 0 is here. 2, 1 is here. So you can kind of see it's going up in ones, yeah? So all we do now is literally just, I mean, of course, use a ruler for here, yeah? You can see that it intersects somewhere around here and somewhere around here. So all you have to do is kind of figure out what that x value is, roughly. So, I mean, this won't be perfectly accurate. I'll probably have to double check the solutions, but here, this is about 1.6, 1.7-ish. So this is what the x value is. And over here, I mean, it could be on this line, it could be on the right, but this is about 4.3 to 4.4. So these are your two solutions, somewhere between these two ranges. So when it asks you, give the solutions, for x, it'll be 1.6 to 1.7. So let's just say 1.6 or 4.3, okay? And that's it, guys. That's it for now.